The next target in your packet is called 37BR. This one is rationalizing denominators because fractions don't allow some things in the denominator. Like you can't have radicals down there, you can't leave it that way. And then, or complex numbers, or negative numbers, or fractions, or decimals, I suppose should be on here. Decimals aren't allowed anywhere in a fraction. So decimals are bad. You don't put those inside of a fraction. Who does that? Nobody. So here's some things that you can't have down there. So radicals being a square root, complex being an I. We don't leave the negative down there. You might as well move it up. And then you don't want to leave a fraction within a fraction because you can do some simplification, is what we're trying to say. So take a look at a couple of these real quick. 1 over the square root of 2, well, I want to get rid of it, so I multiply it by the square root of 2 because then it would be equal to 2. Well, if I do that on the bottom, I have to do it on the top, so I end up getting the square root of 2 over 2. Done. You can't reduce these because that's underneath the radical. Don't you dare mess with that. Okay, that's not anything that can be reduced by 2. I'm going to skip this one for a second, come back to it. Essentially what you would do though is you would take it times 6 plus the square root of 2. We learned about the conjugate idea. If it's 6 minus square root of 2, if you multiply it by 6 plus the square root of 2, it's going to come out to be a whole number, which is what we would want. So then I would have to take this times 6 plus the square root of 2. And so there's a bunch of this kind of stuff that's happening here where you're doing a lot of distributive property and whatnot. So this one doesn't simplify very nicely. The bottom does. You end up getting 34, but the top is kind of messy because you end up getting something that looks like this. So you end up getting 6 times 4 is 24, and then 4 square roots of 2. And it basically works out here. Then you'd have this, then you'd have 6 times the square root of 6, and then you have the square root of 12, which simplifies to this. And then you write all those out. None of those reduce, as far as like simplify together. Like these are all different, so you can't combine them. So it ends up being this, which then they're all even numbers above the coefficient, so they all divide by 2, and so your final answer is here. That one's kind of messy. It's a little bit of work, a little bit of FOIL work. And then the last one down here, you multiply by the reciprocal, so I flip this over. So if I put the 2 as the numerator and the negative square root of 3 as the denominator, I could multiply straight across, or I could see that these are going to cross reduce anyways, which gives me 1 over the square root of negative 3, and then if I multiply by the square root or negative square root of 3 on both of those, I end up with negative square root of 3 over 3, and that's okay. You can have negatives in the numerator, you can have radicals in the numerator, you just can't leave them down there. Okay, a couple others just to look at so you can see what they simplify out to make. I'd multiply by the square root of 3 over 3, boom, get my answer. This one I want another conjugate idea, so I'm going to multiply by 1 plus 7i. A lot of you, what you were doing is just typing it in like this on your calculator. So you type this in with parentheses, this right next to it, and it gives you the answer. Type this in, it gives you the answer. Now it just so happens that all of these are divisible by 10, so then you can reduce that down. And the last one, flip this over, multiply, so those cancel, and you get 1 over the square root of 3, and then multiply by the square root of 3 over 3, and it's square root of 3 over 3.